Greetings everyone, this is Mr. Mullen. This is the second part in my Nomenclature Rules series. We're going to talk about changing a name into a formula for molecular covalent compounds. So let's go ahead and get started. We already talked about ionic compounds, so you can go check out those videos to figure out how to do that. Specifically today, we're talking about how to do these for molecular or covalent compounds. Now, covalent compounds are when we have two or more nonmetals that are sharing those electrons. So how we can recognize a name that is talking about one of these types of compounds is that it will absolutely have what's called a covalent prefix. These covalent prefixes are found in that handout that you have, and I've also listed them here. Prefixes are just things that go in front of words. So mono means one, di means two. So we're talking about how many atoms. So if I have these covalent prefixes, we see these, mono, di, tetra, penta, etc., then you know we're talking about a molecular compound. The only exception is you may see you may see some of these when we're talking about hydrates. It's the only exception. We'll talk about that later. Hydrates. So basically, we're going to go ahead and talk about the rules that you're going to need to name these. Very simple. The prefix is going to determine the subscript on your atom. And it does not stand for the charge. Okay, the prefix has nothing to do with the charge. It just stands for how many. The subscript, we're talking about how many atoms. The other stipulation is that the prefix mono is only needed for the second element. We do not need it for the first, and I'll do an example for you. So let's take a look at nitrogen monoxide. So I look at nitrogen. I see that nitrogen is a nonmetal. Oxygen, oxide, I see that it ends with oxygen. That IDE, remember, if we see that IDE ending, we're just talking about some nonmetal, most likely. So the nonmetal that starts with ox is oxygen. So we're talking about nitrogen and oxygen. Okay, so we have N and we have O. And now we need to figure out the subscript. Well, the subscript is determined by the prefix. So I look at nitrogen, there's nothing in front of it, there's no prefix, it's just nitrogen. So we're going to assume that there's just one nitrogen there. So there's just a 1 there. And I'm going to erase that in a second. Monoxide, oxygen, is going to also have 1 because mono means 1. So 1 oxygen. So my subscripts 1 and 1, because they're bonded together, I'm going to write those capital letters next to each other. And we do not need a 1. So NO. Nitrogen monoxide. We do not need mono for the first element because it's quite redundant to say mononitrogen, monooxide. You can say monoxide. You may also see this written as monooxide. But typically what happens is they will, when you see these vowels doubled, that they will combine them into one. So there's nitrogen monoxide. Let's try another one. Diphosphorus pentaoxide. I see the prefixes, so I know it's a molecular or a covalent compound. They mean the same thing. So di means 2, penta, looking back at the table, means 5. So I have 2 of these and 5 of these. It applies to what's written directly behind it. So phosphorus is just phosphorus, P. I have 2 of those. So P2. And then pentaoxide, remember that IDE is the ending change for an element that starts with ox, and that's going to be oxygen. With oxygen and nitrogen and phosphorus, you're going to see those kind of weird when they get changed over. Oxygen is going to be coming, it's not going to say oxygenide. Okay? For some reason, we cross out a lot of those extra, and we just say oxide. You're going to see it as oxide. You're going to see phosphide. You're not going to see phosphoride. We just get rid of some of those letters to make it more consistent. And this is an exception. You just need to memorize it. Nitrogen's the same thing. You're not going to see nitrogide. You're going to see nitride. So when I see that second, that ending, we're looking for nitrogen, phosphorus, oxygen. So anyway, I have oxygen, and I have 5 of them. Penta stands for 5. So my formula is P2O5. There we go. A quick note about molecular compounds: you will never convert to the lowest whole number ratio. For example, if I have P2O4, diphosphorus tetraoxide, I'm not going to just change this formula to PO2. We're not going to ever convert to the lowest whole number ratio for molecular compounds. That converting to the lowest whole number ratio thing only applies to ionic compounds. So for example, if I was doing an ionic compound, and let's say I had something like tin 4 oxide, and I'm trying to figure out the formula, and I figure out this is +4 and this is -2, and I do the old cross the charges trick. Okay, and we change these charges over. SN2O4. This is where we go to the lowest whole number ratio, because for every 1 SN, I only need 2 O's. This is where we would reduce down to the lowest whole number ratio. That just means I'm dividing everything by one number. 2 divided by 2, 4 divided by 2. I would properly write this formula in its reduced form. Ionic? Yes. For molecular? Never. We never go, because this di literally means always there's 2 of them, so we can't reduce that down to something else. It stands for how many are there for sure in that molecule. Well, this is all I have for you for molecular compounds, and I hope that this was helpful.